Welcome guys. In this session, we'll be looking at the intermediate calculation of indices questions. In further ado, we want to jump into the number one question, which is s raised to the power of 1 over 3 or raised to the power of 3 over 4 times y raised to the power of 1 over 4 or raised to the power of minus 1 divided by x raised to the power of 2 over 7 or raised to the power of minus 7 over 4 all over y all over x, raised to the power of minus 1 over 4 or raised to the power of minus 1 and divide by y raised to the power of 1 over 2 or raised to the power of 4. Before then, let me show you something. If we have y raised to the power of minus z, I told you in the other class, I said for us to remove this minus, we just write 1 over y raised to the power of z. Right now, this case is very reversible. We can write it like this, and also we can reverse it like this. Right, sometimes we'll have stuff like this, we can reverse it to this order, and we'll have stuff like this, we can reverse it to this order, saying 1 over y raised to the power z can be written as y raised to the power minus z. Right, it's always reversible. It's a reversible and recurring process. Right, because of what I want to show you, that's why I'm showing you this. I remember we said if we have a over b all raised to the power of minus c, what we do to remove this minus is to invert them, to write b over a all raised to the power of c. It's a simple case. And if we have this something like this, it can also be reversed. You can either choose to put it like this, or we can choose to put it like this. Please take your sheet of paper, maybe take a jotter or a note, and then put this down, because what we are going to be solving, we're going to be applying these principles to what we are doing. And in order further ado, let's look at the question. See it there. Alright, before we jump straight into the questions, let me show you something. Remember in our last class, I said if we have a raised to the power of minus b, what we do to remove this minus is to invert it by saying 1 over a raised to the power of b. Right? Understand that this is also inversible. I can choose to write it like this. Whenever I see a question like this, I can think of writing it like this, or when I see a question like this, I can rewrite it like this. Right? Yes. It's reversible. We can reverse the process. That's mathematics for you. So another case, I said if we have a over b all raised to the power of minus c, what we do in this case to remove this minus, we invert by saying b over a all raised to the power of c, and in opening this bracket we choose to say b raised to the power of c all over a raised to the power of c. Right? Now please take note of what we just said, because we're going to be applying this to maybe all of the indices questions here. And another thing I said, if we have square root or the cube root of something, 27, we can substitute this, because this cube root also means a power of 1 over 3, right? This cube root means the index of 1 over 3. The index of this base number here, this cube root is the index of this base number. So what do I mean by that? I mean it is 27, and the 27 raised to the power of 1 over 3. Now this cube root here, this cube root, 3 root means 1 over 3, the index of 1 over 3. When we see stuff like this, we can also reinvert them. They are reinvertible. You can choose to see it and write it like this, or we'll see them like this, you can write them like this. Right? And I showed you further way of solving this by turning this power, this base. We're going to look for what we are going to raise the power of this base to, such that its power will be equal to this. And by doing that, we'll say this 27 can be written as 3 raised to the power 3 times this power here, 1 over 3, so that this 3 can cancel that 3. We are left with 3 raised to the power of 1. Right? Please take note of this, because shortly we are going to be applying them to these questions here. Let's jump right straight into the question. How do we solve a question like this? It's very simple. I tell you, it's very simple. Here's what we do. First of all, let's connect like terms. That is to say, let s and s stay alone. Let's push the minus out. And for every number or any variable given, the sign comes before the number. So this sign belongs to this number, and this sign belongs to this number, right? Yes. So what do? I will pick this s, divide by this one, times this one. So we can invert by saying it becomes x raised to the power of 1 over 3 all raised to the power of 3 over 4, right? Divide by x raised to the power of 2 over 7, all raised to the power of minus 7 over 4, right? Yes. And then times y raised to the power of 1 over 4, all raised to the power of minus 1, right? All over x raised to the power of minus 1 over 4, all raised to the power of minus 1, divide by y raised to the power of 1 over 2, all raised to the power of 4. Now look at this. There is a law here. What's the law? Look at these two. These bases are equal. So if we pick it up, before we do that, look at the powers. They can cancel out, right? I can say 3, we take out 3. In this case, I'm left with x raised to the power of what? 1 over 4. That's for this, right? Divide by, in this case, I can say 7, we take out 7. There's a minus here, remember. And 2 here is 1, 2 here will be 2. So in this case, we are left with s raised to the power of minus 1 over 2 because they are all cancelling now. So we have x raised to the power of minus 1 over 2, right? Times y. Look at this. What do we have? We have 1 over 4 times minus 1. This is the power multiplication rule we said. The last law we talked about. If you don't understand it, you can actually go back to the video and check the last law. 1 over 4 times minus 1 here. Or when we have minus 1, we can simply invert. But let's multiply it for simplicity's sake. So 1 over 4 times minus 1 will give us minus 1 over 4. Yes, that's what it gives us. All divide by what? Look at the same thing is happening here. But now we have a clause. Minus times minus is plus. We have a minus here. We have a minus here. So minus times minus is plus. 1 over 4 times 1 is 1 over 4, right? Why are we having minus 1 over 4 times minus 1? Because there is what we call sign multiplication. Look at, there are 4 sign multiplication in mathematics. I hope you can see this. Plus times plus equal to plus. Minus times minus equal to plus. Plus times minus equal to minus. And minus times plus equal to minus. If you don't understand it, just do 2 equal number. If you multiply 2 equal sign, you get plus. Look at the equal sign. If you multiply 2 equal sign, you get plus. And if you multiply 2 different signs, plus times minus, you get minus. Multiply minus times plus, you get minus, right? So look at this. This 1 over 4 has an invincible plus. So plus times this minus. Look at the plus times minus is minus. That's why we're having minus 4 here, right? But in this case, we are having minus times minus. So look at it now. Minus times minus is plus. And plus can be invincible. So we are safe to say it is x raised to the power of what? 1 over 4. Because 1 over 4 times 1 is 1 over 4. Divide by, look at this, we can cancel out, or we can also multiply. 1 over 2 times 4, we can have y raised to the power of what? 4 over 2. That's 2 here is 1, 2 here is 2. So we are left with 2. Or 4 divided by 2 is actually 2 raised to the power of 2. I'm sure you are understanding. And please, if I'm too fast, you can leave. You can just send me a message. Send a message direct to my WhatsApp number, or you can leave a message in the comment section. I'm going to break it down for you. Now look at this. So we have a law here that say when the bases are equal and we have a dividing operator, we subtract the powers, right? We say that in law 2 by saying, look at this law, these bases are equal. So what do? We pick one base by saying x. One of the bases is x raised to the power of what? 1 over 4. This one will make it minus. But we have a minus 1 over 2 here, so we'll open the bracket and put minus 1 over 2, right? Times, we have a y now, y raised to the power of what? Minus 1 over 4. If we divide both sides, we are left with x raised to the power of 1 over 4 divide by y raised to the power of 2. Very good. So what do we do to this? 1 over 4 minus 1 over 2. Remember we said minus, a bracket means to times. When you're seeing anything that has to do with bracket, it means to times. So we have minus times minus. Look at it here. Minus times minus is what? It's plus. So we can come here and look at this fraction here and say 1 over 4 minus bracket minus 1 over 2 can be what? Minus times minus is plus. So we have 1 over 4 plus 1 over 2. Right? And if we do the LCM to this, LCM of 4 and 2 is 4. Right? 4 divided by 4 is 1. 1 times 1 is 1. Plus 4 divided by 2 is 2. 2 times 1 is 2. That becomes 2 plus 1, 3 over 4. So the answer to everything here is x raised to the power of 3 over 4, right? So let's go from here. We can say we have x raised to the power of 3 over 4 times y raised to the power of minus 1 over 4 all over what? X raised to the power of 1 over 4 divide by y raised to the power 2. Right? Let's look at the denominator, for instance. Look at the denominator. Let me show you something separate. If we have stuff like a raised to the power b divided by b raised to the power c, what do we do to this? It's simple. The goal here is to change this dividing sign. Because the bases are not equal and we are seeing the dividing sign, we cannot add this, right? Or we cannot subtract this because the bases are not equal. The only way we can subtract this is when the bases are equal. So when we have different bases, what do? We try and manipulate it. So how do we manipulate it? Look at the dividing sign here. If we have stuff like this, what do? I can change my divide to times by inverting, right? So I can say if we have 2 divided by 3, for instance, it can become 2 times 1 over 3. That's to invert, right? That's what we are doing. So in this case, what do? In this case, what do? I can say it is a raised to the power of b times 1 over b raised to the power c, right? And look at now, we have a law now. 1 over b raised to the power c, like we said the other time, can become what? A raised to the power b times b raised to the power minus c. We said that before. They can be reinverted. You can reinvert them, right? So that's what we're going to be applying here. But look at the denominator. Let's face the denominator for once. Just look at the denominator now. Let's just face the denominator. I'm sure you're understanding what we're doing. Let's face the denominator. In doing this, what happens? We can say we have x raised to the power 3 over 4 times y raised to the power minus 1 over 4 all over x raised to the power 1 over 4. Look at this divide. You can change this divide to times because these bases are not equal, right? So it can be times 1 over y raised to the power 2. Like I said, we have a dividing sign. We can now revert like what I just said. You can just take the video a bit back and then check what we just did, right? And this now has become a law, right? This has become a law by saying we can now reinvert this to become y raised to the power minus 2, right? So it becomes the same thing here. We're not touching this yet. We have x raised to the power 3 over 4 times y raised to the power minus 1 over 4 all over this x raised to the power 1 over 4 times y raised to the power minus 2. Yes, you're very correct now. So we see that both of them, everything now, we have x and time multiplying signs here, right? So look at this now. What if, okay, let me rewrite this. We have x raised to the power 3 over 4 times y raised to the power minus 1 over 4 all over x raised to the power 1 over 4 times y raised to the power minus 2. Now look at this. Just look at this, guys. What if we separate this one and separate this one? Because you see that x and x, they have the same base, and in this case y and y, they have the same base, right? And look at, there is a dividing sign here, a dividing operator here, right? You know what to do, right? Let's look at what to do from the next place. So what do? From here we can say it is x raised to the power 3 over 4. This becomes the dividing line here. Divide by x, that's the denominator, raised to the power 1 over 4. Let's put a bracket to it, right? And then with this and this, they are at the same time. So let's just say it is times, open bracket, y raised to the power minus 1 over 4 divide by y raised to the power minus 2. It's simple now. Look at the base. These bases are equal. So from the law 2, we can pick one, right? By saying we have x, and this, because this is a dividing operator, we can subtract this, right? That's 3 over 4 minus 1 over 4, right? Yes, and we have times, these two bases are equal. We'll pick one, y raised to the power minus 1 over 4 minus, we have a minus 2 here, please, minus 2, right? I will now apply that sign multiplication we talked about. Now let's look at this. Let's do this fraction separately. If we say 3 over 4 minus 1 over 4, what do? We take the LCM of 4 and 4, right? And the LCM of 4 and 4 is 4. So 4 divided by 4 is 1. 1 times 3 is 3. 4 divided by 4 is 1. 1 times 1 is 1. So by doing that, we have 3 minus 1. That is what? That's 2 over 4. and 2 divided by 2 is 1, 4 divided by 2 is 2. Having that, we have 1 over 2. So we can substitute 1 over 2 for this in this, right? So instead of writing this, we can just put 1 over 2 because we've solved this further, right? So this is x raised to power 1 over 2. Sorry, my x is looking a bit bent. X raised to power 1 over 2 times, look at this one. Let's see how we can do this further. Now let's take this down. If we have minus 1 over 4 minus 2, how do we do this? Look at, we said minus times minus in this bracket means to times, right? And so minus times minus is plus. I thought I had my mic off there. So we have minus 1 over 4 minus times minus is plus 2. So this is just 2. We can put over 1 here, right? Yes, that's the one that has been inverting all this while. Let's take the LCM of 1 and 4. LCM of 1 and 4 is 4. 4 divided by 4 is 1. 1 times minus 1 is minus 1. Plus, there's a plus here. So 4 divided by 1 is 4. 4 times 2 is what? Is 8. And so minus 1 plus 8 is what? Minus 1 plus 8. That should be 7, right? How is it 7? I have a way of showing you how you can understand this faster. You can just put a plus and a minus, right? The minus belongs to 1, so we have just 1, and the plus belongs to 8, so we can count in 8. 1, 2, 3, 4, 5, 6, 7, 8, right? So 1, we take off 1 here, we're left with 1, 2, 3, 4, 5, 6, 7, right? So our answer becomes 7 over this 4 here, 7 over 4. So it's safe for me to say I can substitute this for this in this, so we don't have to pull this again, or we've solved this to become 7 over 4. We've simplified it, so we can have y raised to power what? 7 over 4. That's the answer to it. So totally in total, that means in total we can have our answer to be what? To be x raised to power 1 over 2 times y raised to power 7 over 4. That's the simplified answer to this question in number 1. I know it's a bit bulky. If you have a question, you can send it directly to the comment section below, or send it directly to my WhatsApp number on the screen. You can see the WhatsApp number on the screen. Copy it to my screen. You can ask any other question. Let's look at number 2 and number 3 questions and solve them properly to see how we can help you solve your mathematics question in school, JAM, or university question. Thank you very much, guys.
Premium Hill Academy. Morality, ingenuity, and excellence at its peak.